So on this worksheet, you guys, I had you graph this function here, y equals the square root of x, and it should have looked something like that-ish, okay? Now, on the first part, what we did was I said, okay, so there's that one, but now I want you to, actually, instead of y, let me back up a little bit. We were using f of x, but you guys know that f of x and y mean the same thing, right? So instead of writing y, I'm going to write it like this. But then I told you guys, on line 2, I want you to type this. Now, the line looked like this, and so let me ask Crystal, what did that graph look like when there was a negative on the outside?
It looked like it was like the same line as the f of x squared. Yeah, the square root, but it was reflected on the vertically.
Really good language. I like your use of language there. All right. So it looked the same, but it was she said reflected vertically, and that's a beautiful way of expressing it. Good vocabulary. You could have said flipped upside down. You could have said reflected over the x-axis. Okay. So there's a few different ways that you could say that. Someone said reflect. Someone said it's on the other side of the positive line or something like that. I know what you mean. All right, but that's the idea. Now, I also had you guys do this one. Kind of similar, but I had you put the negative on the inside. Okay, and Natalie, what did that graph look like when we put the negative on the inside? That was the first one. That's true. Did you get to the second one where we put the negative on the inside? Okay. What did you see, Adrian? Someone says the same graph, but it just went that way. So your answer for the second blank on your paper could have been worded in a lot of ways. How did you answer the second? What did you say, Denise?
Well, at first I said it made all the x's negative.
Okay, I'll stop there. So that's a great answer. She said it makes all the x's negative. So over here you have a bunch of points, and each of those points have an x value. Well, it's just over here now they're all the negatives, but they all have the same y values. That's pretty insightful, actually. Like this point would be 1, 1. Well, this point has the same thing. It's just that it's negative 1, 1. So that's a good insight. What else did you say? You said you had a second answer.
It was reflected over the y-axis.
Reflected over the y-axis. Now, Crystal said for the other one, reflected vertically. So for this one, you could say reflected horizontally. Yeah. So there's a few ways you could have said it, but that's it. That's the ideal ones you guys get today. These are called reflections. And by putting negatives, basically it takes every point and it changes them in some way. If you put the negative on the outside, it flips them upside down. If you put it on the inside, it flips it horizontally. And I'm going to go back to what Denise said. For the one on the inside, it makes the x's negative. So what do you think it does when you put the negative on the outside?
The y.
It makes the y's negative. That's why it's upside down. So that's the idea I want you guys to get from this. So let's go ahead and now formalize it with some notes and do some practice problems with this stuff. So today we're going to learn what transformations are, what reflections are, how to identify them, and how to write them. Okay? So the first one, I'm just going to give you a definition, but this is where we're going to spend most of our time. What's a reflection? How can you tell when you're looking at a reflection, and how do you write it? And we've kind of already done all of that, but we're just going to make it a little bit more solid with some notes now. So, first of all, what's a transformation? A transformation is something that you do to a function. Like on this one, what did we do to our function? We put negatives on it, right? And that affected the graph. It caused it to have a reflection of some kind. It moved it, right? So a transformation is something that you do to your function that will change various things. It could change its position. It could change its size or its orientation. Now, if you don't know what the word orientation means, that's actually what I meant by reflection. It changes which way it's going. Orientation is direction it's going. So it could change where it's at, its position. So you could actually move a graph. We're not learning that one today. We're not going to like move the graph around. We're just flipping it. You could also change its size. You can make it longer. You can make it taller. You can do a lot of things to it. Or what we did today is you could reflect it, change its orientation, what direction it's going. And those are what we call transformations. And there's three types that we're going to look at. There's translations, reflections, and then these two go together, expansions and compressions. We're looking at this one today, reflections. Okay? So that's what a transformation is. So what's a reflection? A reflection is a special type of transformation where it's either reflected vertically, flipped upside down. So you could write that there. Because sometimes the word, we don't use the word vertical and horizontal a whole lot in our day-to-day language, and so that confuses people. So it just means flipping it upside down. Now, another way you could say it is flipping it across the x-axis. All three of these mean the same thing. Upside down, vertically, or across the x-axis. They all mean that way. Now, you could have horizontally. That means from left to right, or vice versa. So horizontally means moving that way. Or you could say across the y-axis. So those are what reflections are. I see some pencils moving, so I'll wait a second for them to finish. So there's our vocabulary. Now I want to give you this slide that's kind of like the main information of the day that I want you guys to make sure that you have down. Can I delete? Okay. There. All right. So here's a given graph, same one that we worked on our exploration activity here. If you take your function and you put a negative on the outside of it, we saw that that reflects it, and you guys definitely want to be filling in your blanks here. It reflects it across the x-axis. Now, some of you guys might not like that wording because it's not as friendly, but you can add in a little parenthesis there yourself and say, flip it upside down. That's what it means. But I want you guys to know that language because that's what it'll look like on your test when you're picking your choices on the ABCD. It'll say reflect across the x-axis. So if this is confusing to you, then you might want to put in parentheses next to it, flip it upside down, because that's what it means. All right. Now, I'm going to draw this picture then. So what would that graph look like if you put a negative in the front? It flips it upside down like that. So now, what is the equation part? Well, that's this piece here. That's the other side. So when you put a negative on the outside over here, guess what you have to do on the other side? Put a negative on the other side too. So you guys could put equals here and then negative square root of x. In other words, by putting a negative outside the f, you need to put a negative on the other side also. That's what that means. Okay. All right. Now we also had a negative on the inside, right? And we saw that when there was a negative on the inside, it reflected it from left to right. But we're going to say it reflects it across the y-axis. Once again, if that language doesn't make sense to you, maybe in some parentheses next to it, but that means we flip it left to right, or vice versa. So in that case, it would look like this. The original graph looks like this, f of x, but if you put a negative inside the parentheses, it will look like that. So it flips the graph horizontally, or across the y-axis. What do you guys think I'm going to write here? You're going to put square root and you're going to put the negative inside with the x. That's right. So that's that. All right, so that's the main thing I wanted you guys. That's the hub of what we're learning today, right there. And now we're going to do some practice problems. So on the back of your guys' notes, I've got our practice problems, and so we're gonna That way you don't have to write them down, because there's a lot of graphs and stuff on there. Has everybody got this? Need some time? So let's see what these problems look like then. What kind of questions can I ask you? And you guys have all this on the back page of your notes, so you don't have to write these down. You just need to fill in the blanks as we go. So this one, the question is basically asking us, for some reason the directions aren't there. Hopefully it's on, is it on your guys'?
Yeah.
It says describe the transformation. So in other words, just tell me what's going on there. So here's my original function. F of x equals this. This is the original one. Okay? And the question is, by putting a negative here, what transformation occurs? Okay, good. So look at that last slide that we had with that chart. Find the one where the negative is outside of the thing, and look at the description. It says what? Reflects across the x-axis. So if I were to graph f and g, they would look the same. It's just that one would be on the right side, one would be on the left. And it's the same function we just did on our exploration activity. So here's our answer. The answer is, S there. The answer is G is reflected across the x-axis. If you're comparing F to G, G is being reflected across the x-axis. How do we know that? Because there's a negative outside. So if you were to graph F, which you don't need to, but F would look like that, G would look like that. So it's been reflected across the x-axis because of that negative. All right? All right. I'm going to do one more and then I'll let you guys practice. So let me do one more with you. I'll wait a little bit. Now here's something to kind of help you. I thought Denise's input was kind of cool when she said it makes all the x's negative. You remember that? Not this one though. But remember when we had this? She said it makes all the x's negative. Well, that's because you put the negative on the x, right? And when you put it on the outside, it makes all the y's negative. But why does that make sense? Well, we learned yesterday, f of x is just another word for y. So if you put it on the outside, you're making the y values negative. If you put it on the inside, you're making the x's negative. So when you think about it on a graph, if you make all the y values negative, which way does it go? Where does y get negative? No. Where does y get negative?
Oh, bottom.
So when you put a negative on the outside, all the y's get negative. And it goes down here, right? Whereas if you put the negative on the inside, all the x's get negative, and it flips to the other side on the x-axis. So, all right. Let's look at another example. This is an absolute value function. We're not going to draw the graph of it or anything like that. We don't need to. I just want you guys to be able to identify the transformation. So here's my question for you. Is the negative inside or outside?
Inside.
It's inside. When it's inside, what kind of reflection? It's across the y-axis. So we would say G is a reflection across, is a reflection across the y-axis. So whatever this graph looks like, if you were to flip it horizontally from left to right, that's what this one would look like. Why? Because it's the same thing, just has a negative inside. So outside means across the x-axis. Inside means across the y-axis. So I want you guys to do numbers 3 and 4 on there real quick, and we'll give you guys a moment to ponder that and then share out your answers. There are the answers. So that's one type of question where I can give you two functions, say, what happened here? What kind of transformation is that? Now here's another one that I'm going to ask you guys to be able to do with these. I'm going to give you a graph. And you have to tell me, okay, so on these problems, read the directions really quick there. Take a look at those directions, because the directions are a little confusing, but I want you to be familiar with them. So it says, write g of x, which is the dashed line, in terms of f of x, the solid line. So they're telling me that f of x is the solid line. They're telling me that g of x is the dashed line. Now, I'm going to rephrase the directions, but I want you to be familiar with how that's worded, because that's how it'll look on your test, because that's how they word it. So rephrase the directions. And I think those directions wouldn't have made sense to a lot of us, so I would write this down if I were you. Here's how I would rephrase that. What would you have to do to the solid line to get the dotted line? So that to me, I think those directions just make a little bit more sense, but I want you to be familiar with how it's being worded on your worksheet there. So instead of saying write g of x in terms of f of x, the question is really saying, what would you have to do to this blue line or the solid line to get that dotted line? So what would you guys say is happening here? How would I get this blue line to look like the dotted one? What would I have to do to the blue line?
Negative.
Well, that's the answer. But like just the answer, like what I'm looking for is flip it upside down, right? So you just have to flip it upside down. But we don't say flip upside down, right? What do we say? We say the answer to that is reflect across which axis? So if I wanted to make this blue line look like the green line, I would have to flip it across the x-axis. Okay? Now, look at your chart. Find where it says reflect across the x-axis. Where's the negative, inside or outside? So g of x is the one where you should have a negative outside the parentheses. Which one is it?
C.
There you go. G of x is where the negative is outside the parentheses. So what would you have to do to the solid line to get the dotted line? Well, you'd have to reflect it across the x-axis, which means there's a negative outside the parentheses. Anybody still writing that? We good? One more sample problem. I'll let you guys practice. I'm going to bring back those instructions and modify them a little bit. Okay. So, what do you guys think? What would I have to do to the blue line to get the green line? Would I be reflecting it across the x-axis or y-axis? X-axis, the same answer. So it's still x-axis. I still had to flip it upside down, right? So where should the negative be? on the outside. So what's my answer?
C.
It's C again. All right. So that's that. So why don't you guys try the 2 student practices that are the last 2 problems there, and then we'll see what you guys got, and that'll be it for today. And that's where we'll stop for today.